Assalamualaikum and very good morning. We are honored to welcome all participants and honorable speakers to the Smart Grid Roadshow, Smart Grid, a solution to the energy trilemma. Thank you for being here with us this morning. We hope that this Smart Grid Roadshow will become a platform for us to share information and knowledge from panel of experts for the benefit of the society. Ladies and gentlemen, Smart Grid, a solution to the energy trilemma, has become an imperative agenda globally. In the era of increasing public awareness towards social sustainability, society is now demanding business to operate in more ethical, effective and efficient manner. Hence, Smart Grid for sustainability is deemed critical for any business to remain competitive for survival in the long run. With this in our mind, we have invited two distinguished speakers to be with us today. Please allow me to introduce to you our esteemed speaker of this morning. We are so lucky to have Yang Berbahagia Profesor Insinyur Dr. Muhammad Zainal Abidin Abdul Kadir, Unit 10 Strategic Higher Professor in Lightning and High Voltage Engineering, and Yang Berbahagia Insinyur Muhammad Kahar Abdullah, Senior Principal Analysis 2, Sustainable Development Technologies Division, Malaysian Industry Government Group for the High Technology MIT. Now, without further ado, we would like to invite Yang Berbahagia Profesor Insinyur Dr. Izhamin Datuk Zainal Abidin, Unit 10 Team Leader for Smart Grid Project and Dean College of Engineering COE Unit 10, to be with us with our honourable speaker to start the program. Let's get started. Please welcome Yang Berbahagia Insinyur.
Thank you very much, Puan Zurina. So first of all, welcome everybody to our first Smart Grid Roadshow as part of a Smart Grid initiative and collaborative work together with UNIDO, MIT, Unit 10 and also TNB Research. So to kick off this first inaugural talk show, in this case talk show / forum, we have two distinguished speakers with us today. So permit me to introduce them. Okay. The first speaker that we have here is, let me open up. Yes, okay. IR Kaharudin. Okay, IR Kaharudin, thank you very much. Thank you for coming. So a bit about him. He's actually holding the program director, specializing in energy sector at Malaysia Industry Government Group for High Technology, or MIGHT, MIGHT. It is an agency under the Government of Malaysia. Previously, he was the project director at MIGHT Technology Nurturing Division, and he was recruited as a principal analyst or senior manager at MIGHT. His main role is to lead, manage the energy sector, conventional, renewable energy and alternative under Emerging Technology Division, which covers power, oil and gas sectors. And he actually conduct research, perform analysis on emerging technologies related on the energy sector, including fossil fuel-based and renewable energy, to ensure national sustainability being aligned with national forefront in high technology sectors. Previously in MIGHT, or apart from in his career in MIGHT, he was also involved in various projects. One of it is the National Green Technology Foresight GTF 2030, the formation of the Malaysian Smart Grid Community, MSGC, and he is the program manager for GEF6 UNIDO project under Sustainable Cities Development, Smart Grid project to the United Nations Industrial Development Organization UNIDO, which is the project that I believe Alkaha will talk about today. Prior joining to MIGHT, he was the principal researcher under the Fuel and Combustion for Generation Division at Tenaga Nasional Berhad, TNB. He was also at TNB Research Sendian Berhad, and he served Kapar Energy Ventures Sendian Berhad, KEV, which provides hands-on technical knowledge on the operation of coal and gas turbine power plant in terms of fuel and plant operation and maintenance, i.e. condition monitoring, reliability-based maintenance, reliability-based inspection, root cause analysis, and total productive maintenance. So I welcome IR Kaharudin.
Thank you, bro.
So I would like to introduce the next speaker for us today. He is actually one of our strategic higher professor at University Tenaga Nasional, Professor Muhammad Zainal Abidin Abdul Kadir. Welcome. He received his Bachelor of Engineering, a degree in Electrical and Electronic Engineering from University Putra Malaysia, and a PhD degree in high voltage engineering from the University of Manchester, United Kingdom, respectively. He is currently the Strategic Higher Professor at the Institute of Power Engineering, University Tenaga Nasional, and he is also a professor at the Faculty of Engineering, University Putra Malaysia. He is the founding director at the Center for Electromagnetic and Lightning Protection Research, CELP, University Putra Malaysia. He is also an IEEE Power and Energy Society PES Distinguished Lecturer in the field of lightning and high voltage engineering. So I would say welcome, Prof. Zainal, if I can call you the lightning man. Okay, so we have done with the initial introduction. So we'd like to kick off the presentation first with IR Kaharudin to introduce about Smart Grid and how UNIDO and MITE and UNITEN is involved in this particular project. Without further ado, I pass the mic to you.
Okay, thank you so much, Prof. Izham. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh, and a very good morning to the world, which I can say because it's a live broadcasting. Thank you also to distinguished Professor Zainal. I feel honored on behalf of MITE. I'm really happy. I feel proud for the nation that we have Prof. Izham here and Prof. Zainal, a very prominent person in the technology sectors of Smart Grid. All right, to make it more understandable in the context, perhaps we can have a slideshow. All right. We have a Smart Grid roadshow today. It's as mentioned by Prof. Izham, is Smart Grid, a solution to the energy trilemma, which will be deliberated further by both panels. All right. Actually, at my angle, is I can see it's a journey of Smart Grid implementation. Why is it a journey? Because we walk through all kind of sweet and sour story. So anyway, this journey is a journey of Smart Grid implementation as enabler for high technology industry development in Malaysia in energy sector. All right, next slide. All right, basically it's a credit that this project is a global program, is internationally recognized, is under integrated approach pilot project, which is by World Bank, Jeff is our funder, Global Environmental Facility, and the national project manager is United Nations Industry Development Organization, which is known as UNIDO. Next. All right, as I said, since this is a global project under the IAP program, is participated by 28 cities in 13 countries around the world. All right, the total JEF budget, which I have to announce it proudly, is about 130 million, with the co-financing element is about 1.48 billion US dollar. And we in Malaysia feel very honored because of we were one of the selected recipient for this particular program with the co-financing element of 18 million US dollar and JEF direct financing of 3 million US dollar. And in the context of our Smart Grid demo project is specifically done in Malacca. Right, next. Okay, whatever we did for this particular JEF project must be aligned with the global and national context, which is aligned with SDG. And then at the national program, we have 11 Malaysian plan where we coin back to 11 Malaysian plan. And now we have 12 Malaysian plan, right, Prof?
Yep.
Okay, this is how important this project. It's a long journey, that's why I term it as a journey. And then the local, which is the custodian of the project in Malaysia, is actually at MITE. And then if you can refer here, the SDG number 7, number 9, and number 11 is very important for this particular project. Next. All right, why people talk about sustainable city? People mostly talk about green cities, competitive cities. So sustainable cities encompass of three pillars, which is economic driven, with term as competitive cities, environmental driven, term as green and resilient cities, and a social impact, which is livable and inclusive cities. The smart cities is actually the enabler, which is become the foundation of our sustainable city. So basically, sustainable cities will be covered economic, environmental, and social aspect, where the element of smartness will be cross-cutting. All right, next. Okay, again, to recap the word of the day for myself is actually journey. We have a JEF4, JEF5, which is a series of JEF cycle, where now we have JEF6. And then Prof, since we have Prof Zainal also lightning man here, which maybe I can recap about JEF5 is maybe to the area of interest of energy efficient low carbon transport. And then we have JEF4 also, which is on the energy efficiency with Malaysian manufacturing sector. This is how we look the journey of from JEF4, JEF5 and JEF6, where we have now we look at the more wider scope, sustainable city development in Malaysia. All right, the element of the direct financing amount is, as I mentioned earlier, is USD 3 million. All right, next. Okay, this is about the national program, all the stakeholders. Okay, we have the program contact point, which is KPKT, is the National Steering Committee Chair. And then we have Mike and we have UNIDO. And then these are all the incorporation partners, which is we have KETSA, we have EPU, we have MOSTI, we have MCMC, and all the various parties, which is not just a partner, but also delivering partners to the successfulness of this particular project.
So it's very comprehensive. Huh?
Yeah, it's comprehensive. It's really talking about from the ministerial top level, internationally bilateral agreement, and then to the agency, and then up to the G2G, and also business to business later on. All right. Okay, next. Okay, as I mentioned just now, okay, we have these global partners. We have national and state partners. Okay, national and state partners, I recap again, is KPKT. We have Melaka, a credit to Melaka Green Tech Corporation. And then we have MIC, and the Sustainable City Integrated Approach. As I mentioned just now, we have these pillars, 3 pillars, economy, environmental, and social. And then the project scope, which is, all right, a lot of people talking about, okay, we have so much theoretical paperwork, policy driven, but what's need to be done at site? So myself, together with all the stakeholders, UNITEN and TMBR had this concerted effort, not just capacity building and awareness, but also the smart grid demonstration project in Melaka. All right, next. Okay, this is about IAP approach on JEF6 project structure, the governance side, World Bank, JEF, UNIDO, and we have National Steering Committee, which is KPKT, and then mine as the PMU, and we have also this steering committee. Okay, this steering committee is a very, I feel honored, because in Malaysia, everybody try to contribute, Prof. Zainal, everybody try to contribute towards their expertise. Example, we have technical committees from the ministry side. We have the technical committees from various ministers. And then why this technical committee is being set up? Basically, they advise us on the policy and strategic direction, capacity building, like what we had yesterday. Prof. Izham had steerhead for the 2 days capacity building program. And then we have awareness, like for today, it's a very big event for our awareness program nationwide. And the last one, which is another scope, is actually the Smart Grid Demo project in Melaka. Next. Okay, the project governance, we have Mike here, we have the chairman. Okay, credit to Suruhanjaya Tenaga, where they are the chairman for our Smart Grid Technical Committee. Okay, the project again, maybe I would like to take this platform. Nowadays, the world is not about who can do and who cannot do. It's about collaboration. And what Mike always embrace is about the spirit of collaboration. One of the spirit is actually having the PDP, which is termed as Project Delivery Partner. All right, where we have here for component 1, 2, and 3 is actually we have UNITEN, headed by Prof. Izham. And then for component 4, we have, which is our neighbor, which is TMB Research, headed by Dr. Sheikh. All right. These are a series of engagement. As you can see the photos out there. It's a journey. It's a lovely journey. All right. Okay, next. Okay, again, smart grid deliverables, as I mentioned you here. Okay, we have policy framework is a kind of engagement at very high level. Okay, where we have to develop policy and regulatory framework. Okay, where the details it will be deliberate by Prof. Izham perhaps, and then we have capacity building. Like yesterday, we had almost 80 packs online. Credit to Prof. Izham. We received a lot of international engagement also on the capacity building. We have awareness. Like today, we have a very good awareness program. Previously, we have Facebook and also Instagram. All right, and then the demo project is the one which people can also materialize. Maybe the lightning man would like to see how the impact of this lightning on the smart grid project. Okay, next. Okay, these are the series. Okay, I purposely put all these photos way back 2015 because the one which we can see today is not the year of 2020. It's actually the hard effort and the sweat and the sweet and sour story, Prof, from the 2015. Because this is international, we have to really perform to the eye of United Nations and Jeff, then only our country will be selected. Okay, now people can have access to all the media social, then everybody, the whole world can access to our program, all right? So way back 2015, we have prelim meeting, and then we have town planning department meeting, and then we have a national workshop. Wherever our framework and thought inside this particular project, we do have engagement via workshop, basically, all right? And then we have a series of special briefing, pre-council, national steering committee members meeting with a lot of debate and challenge, because electricity is not a joke, it's about compensation and reward, all right? Okay, next. Okay, this is what we have with United Nations, and we have also cross collaboration with other parties such as UNDP, UNEP, and because Jeff is also cross-cut, not just for United Nations UNIDO, but we also have linkages with UNDP example. All right, these are the example where we had met with the municipality. That means we are not just top-down approach, but we also from side and bottom approach, which is like we had linkages and various meeting with municipalities, Green Tech Council, and BSIP. BSIP is another program where on focusing on energy efficiency program, and really a lot of engagement with TMB. I think TMB is the main co-financiers for this particular project. All right, next. Okay, this is our National Steering Committee way back 2018, and we had a close engagement with the Malacca State Department on the smart grid, which focusing later on, this focusing on this project is energy efficiency, large solar scale, and also net energy monitoring. Right, next. Okay, next time I feel honored to host such a very big program at MAI. We had a very good facility where we host the workshop and also a techno talk with smart grid project. I think is the thing which we need to project is a very good techno platform at MAI, where we gather all the industry stakeholders, voice out their concern, not just doing the project per se, but the smart grid in the context of Malaysia. Why we are so important? Like yesterday on the capacity building, maybe Prof, the geographically Malaysia is very important. How to position ourselves in terms of smart grid, because we have Thailand on the top and we have Singapore at the bottom side. How does this our smart grid will be for the future of 2030 or 2050 or another next 10 years for the planning program? I think we should later Prof Zainal will deliberate further. All right, next. Okay, again, not so easy to do this one. Electricity, a simple layman can, everybody can be electrocuted, but dealing with maximum demand with how much energy production, demand site management is something not a joke, Prof. I think the expert is here. So we really did a technical site visit, technical site assessment here and there, crack our head. But the good thing is, I can proudly say, Malaysian is very well knowledgeable, Prof. I think kudos to the academia, because we can defense during the project challenge sometime. All right. Okay. Next. Okay. Meanwhile, okay. As I can recap, maybe in a nutshell, since we have 4 components. The component 1 is actually smart grid regulatory framework. We need to have overarching. How does this smart grid regulatory framework, where MAI together with Uniten is collaborating very well, and then well guided by Suruhanjaya Tenaga Energy Commission in this context, how our smart grid architectural model in the context of Malaysia will be looks like, right? It may be different from our neighboring countries. Definitely will be different. Right, next. Okay, this is existing registration review. As I told you, from this slide, we can see like, in order to craft the regulatory framework, we need very thorough registration review. We cannot be business as usual, but business unusual, because the imaging of technology is is very fast, very rapid.
Yes.
Okay, and then next. Okay, the component 2. Okay, again, yesterday we had a very good turn up for the last two consecutive days, Prof.
Yes, 2
Okay, on the
days.
capacities building nationwide deploy, and as I can project, as everybody can see via screen, we have a series of engagement, mostly every month. So I take this opportunity as the project co-own at MIC. Please join this smart grid training. Okay, it's me personally, it's exciting because at the end of the class, like yesterday, Prof. Izan talking about cyber security. It's very exciting. All right. Okay, next slide. Okay, on the awareness achievement, all right, which is on the component 3, we have various type of media social platform. One of it is Facebook. The other one is actually on Instagram, and also website coming soon. Okay, if I did, Prof. Zainal, I did a comment trail. I saw the comment trail. I can see the level of maturity of the people embracing here. Okay, can you imagine, let's say my son really just want to see what's they doing. Okay, actually this is kind of directly telling our future generation how the smart grid for smart nation. Then I say, okay, son, okay, you just go through my daddy's website, because I tag to this smart grid for smart nation. Actually, it's very good, because the future is not me anymore, it's my kid, it's our
It's for the
kids.
children.
And maybe Prof. Izhan, great granddaughter, will be able to see this type of thing. Right, next slide. Okay, this is the Instagram. Okay, we do have a very close engagement also, where various photos being uploaded. Is kind of interesting. All right, next. Okay, this is the important part. We have been talking about so much philosophical. We talk about policy, capacity building, awareness, and this is the real demonstration project.
So this is the demonstration of the actual system.
Yes, demonstration of the actual system in Malacca, where we have all various stakeholders. We have phase 1, phase 2, and phase 3. We have all these technology component. I think I need to spend some time, Prof. In this one. Okay, a lot of people know about smart meters. We have enhanced time of use, solar PV, energy storage system. This is the future of the technology trend. It's important, regardless of type of energy storage. I think under Prof. Izham team really well deliberated on energy storage system. We have building energy management system, EV charging station. I think where the Lightning Man will be much concerned on the EV charging station. They need to protect our system well from the lightning strike. And then we also have solar thermal. We also have home energy management system, building energy management system, EV vehicles integration, and importantly now, the hot topic in Malaysia now is actually LSS4, Prof. Okay, where the injection of this mass rollout on this last solar scale round cycle number 4 on the solar farm, and also net energy metering. All right, next. Okay, this is try to show the idea of the overall project, how much capacity we expect. Example for phase 2, I just pick one phase 2, Prof. We have 5.13. Okay, phase 3, we have 31.13 megawatt. So you can see phase 2 and phase 3 is actually again a journey from the 5 megawatt capacity of one solar farm PV in Malacca. We upscale it to 31.13 megawatt.
So it's like 6 times more.
6 times more. So the maturity and the drive of technology in Malaysia, I think I have to kind of salute them and respect how people like very excited. We in Malaysia, Prof, we don't have a massive land bank, but we still able to do it. This is a journey of how Malaysia really did it. And then again, we have the commitment. Maybe next slide. Okay, we have, wherever we did, again, we have the commitment to the funder, which is Jeff in this context, on the greenhouse gas commitment, which is we have about 46,000 tons of CO2 equivalent per year. Okay, GHG reduction. And over 20 years, we have 84,000 tons of CO2 equivalent, direct GHG reduction, and indirect GHG emission. So this is important, I think, because of COVID also. Now everybody try to be more concerned, spend more with less, I think. So now how we want to migrate between conventional fuel to renewable energy fuel. So I think this is the one, and I think I have the last slide. I think okay. Thank you from my organization, and then from myself. I feel honored to be with these two distinguished, prominent person in the electricity industry. I hand over back to you, Prof. Thank you so much.
Thank you, Arkaha. So thank you for the first set of presentation. I think it opens up the discussion today, where we want to discuss more on smart grid per se and how it would relate to the energy trilemma. So for our viewers today, I can see in some of the questions here. Don't worry, the live session will be recorded, and we will share the records later when the live session is finished. Okay, so now that we have already set the scene, where we talk about sustainable city, we've talked about smart grid. So I think now is a good time for us to hear from Prof. Zainal. I believe you have some presentation in relation to smart grid. So I would like to pass to Prof. Zainal.
Okay, thank you very much, Prof. Izham, for the generous introductions earlier, and also I welcome Arkaha, our colleague here from MIC. I think perhaps we can see a couple of slides, to kick off, from the technical perspective of the smart grid. So let's see. So as the title for today, which is a solution for the energy trilemma. So we have several key points that I'm going to give a brief because we don't have much time. Perhaps we can have like a much better, in terms of the time later. So we can see I'm going to start with a global energy outlook from the whole perspective, and next one is going to see the smart grid, a brief on the smart grid. The third one, where are we from the perspective as a nation, and last but not least on the way forward next. Again, what you can see on your screen, basically a transitions in terms of the global energy development from 2015 to 2050, which is from, I think, almost about 35 years time. What I've tried to actually highlight here, if you can see the opportunity, especially when it comes to the RE development, you can see from 2015, especially in solar, from 1% into about 70%. So it's huge jump that's actually translated into I would say the energy generations, and also translated into opportunity, for the country or for the whole, nations. Next. Yeah. So from a mission perspective, so we can see in terms of the energy usage, again, it's big jump from 1997 in 2017 for about 10 years. And also from the installed capacity, demand, and generation perspective as of 2018 for Peninsular Malaysia. So you can see how much we have installed, we have demand, and also in terms of the generation, which is almost 126 terawatt hour. So which is huge, for the country. So next. I think as we said earlier, when it comes to the smart grid, I think everybody's wondering, what is the smart grid actually? So regardless whether there is the IEEE, SEAGRE, IEC, or EPRI definition, it comes to the same conclusion. It's all about the concept of the modernizing the grid. Through the, by integrating the electrical and also information technology at any point between the generation side and also to the consumer, consumption. So this is where the opportunity, that we as a nations, from technical, from the economical side, can really contribute. Next. I think the graphical illustrations give us, much better idea to better understand, when it comes to the conventional versus the smart grid. It's very simple, very straightforward. When it comes to the conventional grid, which is you can have just a simple one-way power flow. It's very straightforward in terms of the interaction and so on, from the generation, step up, transmission, step down distribution, and so on, until the consumer. But when it comes to smart grid, you can see we have different, stakeholders involved. We have a fully or highly integrated, network, which is, again, it looks complex, but on positive side, it gives us much better perspective in terms of, we're talking about the protections, we're talking about the generations, the IoT and all those things. Next. So what are the smart grid elements? So this is like highlighted in the IEC Smart Grid Roadmap 2010, which is that covers several aspects from the markets, operations, service provider, customer distributions, transmission and generation. So these are all the again the platform or the elements that we can contribute, and when it comes to the smart grid. Next. Again, the smart grid itself is very huge. It may not be covered in 20-minute presentations, and also maybe just a very short time of forum, but it should come as a sequence of interactions, and so on. But as a guide, we can see there's a lot of publications, either from the textbook, standard, and also guidelines from several, I would say, institution or agency, like the prominent one, I mean, in the IEC, from the standardizations organizations, CGRE, IEEE is a learned society, and also from several handbook and also roadmap that well published in the literature. Next. This is very, very important aspect. I mean, when it comes to the smart grid, we need to know what are the drivers. It may not be at the implementation level, but I think at the top level, because this has to be clearly, debated and also discussed. So as you can see here, we can see, in some countries, the drivers are different, from different perspective. Some of the countries focusing on the low carbon, some of the country focusing on the economic growth, and some of the country looking into the infrastructure. But what we're trying to actually explain here, or rather to address here, is if you can see the chart there, you can see why the emerging countries, is something that we need to actually monitor, because when it comes to the consumption, for example, it's driven by strong long-term economic growth, and also the applications or the aspirations of the rapidly growing middle class. So, and also the second point, in terms of the high capacity power lines that enable long distance electricity with other infra also, that makes why the emerging countries is really, really fast drive this smart grid, as opposed to the OECD, which is as well well developed country. There's not normal, but it's very small population growth, and also very small demand. Everything is there already. Next. When we talk about the smart grid, I think the idea of knowing what will be the challenges, especially for countries. Again, we have a lot of issues when it comes to business and financing, regulation, awareness. Is what we did, is what we are doing at the moment. But when it comes to the common issue or challenging things, especially for both advanced and also emerging countries, is the need for more public fund and also the tariff incentive. So I think that whether that is for R&D, whether that is for the demonstration project, as what Mike is doing at the moment, and also for the full system deployment. Next. I think the key point that discussion is about the 3 E's. What are the 3 E's? And some people actually most probably the first time that they have heard about the trilemma. They have heard of dilemma before, but when it comes to the smart grid, perhaps people were asking that is it going to be like the key like sort of concept that is going to solve this energy trilemma, which is in terms of the energy security, the environmental sustainability, and also the energy equity. So those each aspect contains of several points. Like for example, energy security, we're talking about the different resource diversifications. For example, when it comes to the environmental sustainability, we are talking about a COP21 target. And when it comes to the energy equity, it's all about the cost effective from, either to the consumer and also to the producer. So next. So this is clearly written, and you may find from the Energy Commission website. When it comes to the energy security, what I have highlighted basically is a key point. It's all about the reliability, availability, efficiency, and also quality of the electricity and also the energy. And of course, we have several actions in terms of the target, and as what I have mentioned before, for 20 years, forecasting that we will expect, the RE increment, say from 1% into most probably like 20%. Up to a certain period of time. When it comes to the environmental, sustainability, so the target basically, or rather the keyword is decarbonizations. So how fast we can go, and how well we can actually, we have pledged, and how well we can achieve, whatever that we have pledged, for, through the SDG and so on. And last but not least, on the energy equity, which is it's all about like I would say like the effective cost. As I mentioned, the balance, whatever from production and also from the consumer perspective. So next. And from our perspective, or rather from the producers, of course, most probably the easiest for us to understand is we are talking about, we as a user, we do not want any interruptions, to our electricity, the daily usage. Likewise, for the power producers as well, which is there are certain criteria that they are actually focusing. That they have to. It's just like a KPI. You have to look into the SAIDI, SAIFI, and also KAIDI. Like say, for example, when it comes to SAIDI, like how many minutes of the interruptions for customer per year, felt by the consumer. So the faster, or rather the lower the duration, which is the better the performance. That's
so
how we
generally we have been improving.
Correct. I think that we can see, because it's very good sign in terms of how the TNB in our case improve the quality. In all aspect, as you can see clearly from the reduction of the SAIDI. Next. And when it comes to the news clipping, the informations, because I think before the project demonstration, most probably we as a public, including myself, for example, most probably we have heard some times ago, but we are not sure. Where are we at the moment? When it comes to smart grid implementations. But we have seen that at least I think since 2011, for example, people are talking about it. From the TNB perspective, regulator, and so on. And in fact, you can see from in 25th July 2018. So we can see an effort made by the TNB in terms of how much the investment that they have made, and also the implementations of the smart metering, for example, in Malacca and also in Klang Valley. Next. So where are we? So this is like, I think, well published and well written. Actually, you can see there's several phases when it comes to the, I would say, the energy efficiency or energy improvement, or rather the smart grid improvement and so on. But I think 2018, we can see how TNB is pledged in terms of trying to be a top 10 utility, globally, by 2025. And I think prior to that, of course, there are a lot of injections in terms of the capital investment. And apart from that, I think the interesting point is how much, the money is going to be allocated, for the smart grid implementations, which is 2.7 billion, that translated into, many, I would say, key actions, for that. Next. So, of course, with permission from TNB as well, I can say something here that it's also something that we at the universities, and in particular UNITEN, are engaging in several key projects. Of course, we can see from the ST, from the SEDA, and from the ministry perspective. So we have started the feed-in tariff last time, and again going to the net energy metering that we have at the moment, and the large scale solar, as what you mentioned just now. Now we are going to go for the phase 4, or rather the cycle 4. From the utility perspective, we can see the digital substation automation, for example, how this IEC 61850, going to be focused on, I think, digitizing, the system. When I say digitizing, it's all about, like, say, for example, the self-healing grid, how the information is going to be transferred. For example, the big industry like Siemens and ABB, for example, like came out with the intelligent transformer. So you don't have to go to the site, get the oil and so on. So everything will be done in situ. The result will be processed, will be monitored, will be transferred into the substation, digital substations. And we, as the, I would say, engineers, we're just sitting in front of our desk and we can control everything. So that will be the key, I would say, how the power system is going to be transformed. And the DLR, we call it the dynamic line rating, which is very, very crucial. At the moment, what we are doing, I'm going to spend some time here because it's very, very important. So at the moment, all the calculations when we design the electrical power system is based on the static calculations, how much the energy can be pumped into the system based on the static. But when it comes to the dynamic, there's opportunity for us to actually increase, how much we can pump the juice, I would say so, or pump the electricity or the current through the grid, knowing that it's going to be dynamic, accordingly to the, say, for example, solar irradiation, to the wind direction, to the angle, and so on. So it gives us two benefits in terms of how we can actually reduce the volume of the loss and also the stress from the generation perspective. So these are the things that what we are doing at the moment, from the research perspective. Another thing is that we're talking about the self-healing grid. We're talking about how the power system protections can can detect and can inform us so that we can take any action, which is, for example, through the automated fault actually classifier. So we can see once fault happen, so the system will detect and tell us, okay, what kind of fault, and what will be the next action we're going to do. So next one is, which is very, very new, I would say, the Wicho power plant, which is how the energy storage, penetrate the grid. So if you can imagine, you can have your battery to be installed as most probably to support during the peak, I would say, tariff or the peak, like demand, that you can, help to actually reduce a bit. So in terms of the stress, in terms of the capacity, or perhaps in terms of the cost. So that will be from the TNB, and also we as a user, we can have our own as well. And last but not least, how we can strategically managing, the asset, which is through the GIS, the geographic information system, which is, this is the new things, I would say, around the world. You can see the historical informations of your selected, asset, and that will give you the privilege, to control, to manage, to plan, and to plan means whether to replace or to maintain the asset. So this is how the things, from the research perspective, and comes to the demonstration as well, that is happening with TNB at the moment. So next. So as a way forward, I think we have seen so many things, so many initiatives, taken by UNIDO, MIC, and of course UNITEN and TNBR as well. But I think overall, so these are the things that we should focus, or we can perhaps concentrate in terms of, we need to have a clear vision, a clear roadmap, that it's not just for us for us mean from the regulatory perspective, or from the the key the decision maker, but also that should be well aware, up to the public as well, so that they can help to actually, I think, support when it comes to the smart grid idea. Second one is on the stakeholder support and role. I think, as I said, that's very, very important, because it's not like a one-man show, for example. So it's going to be well fed, by all the stakeholders. Again, from the generation, up to the consumer. And we need to have the test bed, which is, I think, it's a good thing that we're going to have the smart grid demonstrations, in Melaka, that to show us, the implementations, and how we can actually keep updating the public, especially when it comes to the progress. And we have seen the Jeju, for example, test bed. We have seen the Japan or Japanese smart grid test bed. So I think, again, as you mentioned, we should play our role being in this particular region, having all the ASEAN countries, that we can perhaps, being the pioneer, in our region. Next is human capital. Again, the 2 days training conducted by Prof. Izam, for example, that's a good start, at least, for the capacity building. The research, development, commercialization, and also innovations. I think, again, that should be played, of course, with the support from the ministry, that should be played by the research institutions, because I think this is our bread and butter, like to really focus what are the, the things, the elements that we can help, to make the smart grid is really a successful story. So last but not least, on the policy and regulation, this is very, very important. I would say crucially important, because without the policy in place, without the initiative and also incentive, so everything is going to be difficult, to be implemented. So I think, in very brief, this one slide tells us, what should be, I think, the whole perspective, to make the smart grid successful. Next. I think at the end of the day, when we're talking about the power system transformation, for example, we're talking about the highly integrated power system, from the different resources of the generation side, from the protection, the IoT, how you monitor the asset and so on, until the consumer, which is, we have the opportunity to become like a mini or independent IPP as well. Through the energy storage, for example, through the solar PV that we install. So again, So whether you are producer or whether you are the consumer, you can play your own role. But I think a much better awareness again should be played by all again to make the whole things highly integrated power system. So I think most probably this is the last slide. Yes, thank you. So I pass to Prof. Izham.
Oh, okay. Thank you very much. I was waiting whether you wanted to explain something on that. So thank you very much, Prof. Zainal. Very interesting presentation. I believe to our viewers out there, if you want to post any questions, feel free to ask. I think there's a chat function in there for you to post your questions. Okay, so there are some questions already in. Maybe for Al-Kahar. They were quite interested to know about this upcoming demo project. Maybe if you can explain a bit more on that.
All right. Thank you, Prof. Izham. And to the person visually asked. All right. First of all, all right. In the context of Malaysia, we have this demo project in Melaka. All right. The demo project in Melaka selected again. A lot of people ask why Melaka. The question I can summarize. Correct me if I'm wrong, Prof. Okay. The important part is actually the grid concern itself. The nature of Melaka, because Melaka actually is very small state, right? We cannot afford to keep building a big pylon. So that's the important part. And then the drive for the green technology application in terms of solar PV, they are very much advanced. In fact, last time, Melaka green state cities, all right, yes. Where they have a lot of drive on net energy metering, they have this solar PV. The first one, with the permission of the Melaka's stakeholders, I would like to announce and salute them because of they came in with the 5 megawatt, where people still at that time still thinking whether the solar really can inject the electricity or not. All right, so the selection of Melaka is very important, and the grid nature of Melaka, where they have, if I'm not mistaken, 275 kV in the context of industry player, where high-tech industry, where they has a lot of high-com industry center is there. So we cannot afford to fail our grid system. Yep. All right, the upcoming one, okay, back to the question, is a concerted decision. Again, it cannot be plug and play anywhere in the peninsula. There are a lot of parameters which we need to outline, and being already outlined and to well define where is the next stage after the marker. All right. Anyway, this type of language, it is most suited well way back 10 years ago, Prof. But now, as what Prof. Zainal mentioned, is integrated grid system where they have SAIDI, SAIFI, CHAIPI. All these sort of technical parameters is being well judged by the FDI, foreign direct investment, yes, and direct investment. Okay. So anybody wanted to come in, do big investment in Malaysia for high-tech industry sectors, they really focus on this one. They will do the benchmark. So to make sure our grid is ready, SAIDI, SAIFI, CHAIPI kind of stuff, it need to be not just Melaka, it need to be overall. So this is how from the national view, we can see like the one which is in Melaka is good. They are doing the fronting side. The next one, we have a lot of parameters need to be considered. Anyway, in a nutshell, I can say Melaka is doing well for the Smart Grid Demo project. And please contact all of us to know what is the real demo project. It's not just theoretical, but it's also practical. All right, I hope I answered it.
Thank you very much, Eka. Maybe one question for Prof. Zainal. Relating back to your slide, you talked about the smart grid and the energy trilemma. So how would you gauge, would it, let's say, before having smart grid and after having smart grid, how would it relate back to the energy trilemma issue that you showed just now?
Okay. It's a good questions. I think there are three key aspects when it comes to the energy trilemma. I think both, as I mentioned, like from consumer perspective, they can play their role. Also at the same time, from the producer perspective, I mean in this case like TNB, because now and then you can look basically from different, I mean from the conventional grid, which is very simple, straightforward, versus when you have the smart grid, which is everything will be highly integrated. So when it comes, say, for example, in terms of the energy security, we're talking about the diversifications of the resources. So again, in this case, whether TMB or whether we as a consumer, we can have our opportunity. Say for example through the feed-in tariff that was offered last time, and now through the net energy metering, which is surely you can save your monthly bill. So it's very straightforward. As for the what we call for the power producers, of course they can have their own what we call the say for example solar PV that can most probably, or rather some portion of the energy generation should come from that. So it's not just on the issue of diversifications, but also most probably during the for the emergency solution. I think it's very well defined in terms of the energy security. And then when it comes to the environmental, for example, you're talking about decarbonizations. So how we can play the role? So as simple as like having the conventional grid, versus, so say for example like the solar PV. So you can reduce in terms of again remember the KTOE, which is the kiloton of oil equivalent. How much the fuel need to be burned to generate the electricity, versus how much the sun that can give you say several kilowatt hours or several kilowatt. So it's very straightforward solutions. And likewise for the last thing, which is on the equity, which is like for the consumer, for example, through the net energy metering or through the feed-in tariff, it's not just again to cater the diversifications, to cater the environmental issue, but also you can generate like the passive income, for the household. The net energy metering, which is in terms of how much you can save the energy. We're talking about the like the high bill and so on. So this is the opportunity. So it's just a matter of like knowing what you are what you are doing, what is your problem, and what needs to be done. So I hope that will answer the questions.
Okay, good, very interesting.
Yes.
Maybe if Arkaha can add, what would be from, because MITE is a body from the government that look at this high technology solutions. So would you think smart grid would be the answer in solving this energy trilemma?
All right. There are two to three type of things that I need to embed in this question. All right. Maybe from the view of point where I came from, where MITE is the agency of the government of Malaysia. Actually, looking at the current situation now, I try to, Prof, for example, I try to look at the current situation now where investment is very important. All right, it drives job, employment, it reduces poverty index, it gives a job creation. So we have two types of investment, basically, foreign direct investment and domestic investment, all right? To some people, and most of these MNC or big GLC, they really look at this grid readiness. Because grid readiness, last time, okay, one of example, in one factory, they can host for 1,000 numbers of employees. But now, because of we have this new normal as being announced in Malaysia, a lot of large power consumer, like example factory, semiconductor industry, they have to run maybe from 2 shifts into 3 shifts because of the social distancing. So night time, last time, we have this, we can say like, okay, our peak load is during daytime, right? But during COVID post-COVID era, we might see the peak load shaving may be different. So during night time may happen the peak shaving, where we have this type of problem of how to harvest the renewable energy during daytime. Then Prof. Zainab will come in. Okay, we might have this energy storage at a certain extent, all right? The maximum demand profile. But from the angle of the high-tech industry development, it will be a challenge. And one of the challenge solution is actually to have the grid well integrated via the system of smart grid. So that's how the importance of this smart grid. From the national point of view, the policymakers, we really need to make it, as what Prof. Zainab mentioned, it's become a very crucial thing now. All right, we cannot keep letting our, apart from the practitioner, we mentioned the physicists, we mentioned, right? All right, power quality, anti-islanding, harmonics, kind of stuff. But how we want to make sure the cost competitive, LCOE people is talking about, because we need to be competitive regionally and also globally. All right, so I hope answered your question.
Thank you very much. Now I can see a few questions coming in now.
Okay.
So we'll try to choose. Unfortunately, we can't answer all. Okay. maybe I can combine some of the questions together. So about the smart grid demo project in Melaka, there's a few asking whether does it actually involve IR 4.0 technology, one. And there was a question, why Melaka but not Putrajaya? So I don't know, that's something that probably, I don't know whether we can answer that or not, but maybe we can discuss that a bit further. And the next one related to the demo project would be standards. Will there be any new standards coming up from the demo project? Will we be developing our own standards, or will we be adapting other standards to actually match to what we have? So maybe who want to try and answer first? Maybe Prof. Zainal first.
Yeah, I can not on that Putrajaya versus Melaka, but also about on the from the IR 4.0, and also the last question which is on
Smart grid standard.
Smart grid standard. If you look at, I've just shown earlier on the screen. I think as simple as looking at the elements of the smart grid itself. Again, and in fact, I've shown a reference which is how the IoT play the roles in the smart grid. I think we need to understand again. It's just like even IR 4.0. I think it's just like concept of the smart grid. I think everything will be. We're talking not just on the IoT, but almost IoE, which is Internet of Everything. So again, we are talking about how you're going to monitor your asset. Again, as I mentioned earlier, you don't have to go to the site, like say as simple as like open the tank and take the oil, an oil sample and then bring to the lab. So everything should be automated. So this is one of the key things. Another thing which is again when it comes to the decision making, when you have a certain fault, on the power systems, how are you going to decide that? Are you going to send, your people to the? Of course, we are still doing it, but we are talking about smart grid. We are talking about, the smarter system, which is less people, less time and less energy. In terms of, solving a certain problem. So the IR 4.0, is more on like again, coin on the same aspect of, like we're going to have like more. Like robotic, the deep learning, so-called artificial intelligence. So this has been done, for quite some time from the research perspective as well. And in fact, in some places, they have even the test bed for that. So again, those are the things that surely is there. When it comes to the IR 4.0, it's just a matter of how we understand about it and how we're going to focus and to implement on that. And then on the second thing, which is on the standardizations, I think again, as I said, when it comes to the smart grid, it's a framework. Good things, to have something to start with. Like we have the IEC roadmap 2010, for example. We have the IEEE. In fact, IEEE transaction on the smart grid, particularly developed to focus all the publications, all the research on the smart grid, So from the moment the country, I would say embark on this, and you can start to see, for example, now, how are you going to see the LLS, the large scale solar LSS. So it's going to penetrate the grid. Most probably previously you're talking about the penetration at the distribution level. So now you're talking about the penetration at the transmission level. So do we have the standard? No. So we're going to do that. Even in my area of lightning protection, still. At the SIGRE and also the IEC, we just established a working group on that, because previously, people just take for granted when it comes to the lightning protections, but now people need to see, because the understanding is different. Like from the moment, so you may not require the lightning protection on your house, for example, but from the moment you have your PV system, you're going to have your inverter, you're going to have your rooftop to be protected, and so on. So that requires a new standard to be written. So that depends on the step that we are taking, but surely again, we're going to have that based on at least the fundamental roadmap or the framework that has been established in SIGRE, IEC, and also IEEE, just to say a few. Thank you.
Okay, so maybe Alkaha, your take?
All right, first of all, this is a very catchy terms in terms of IoT. Perhaps also what Prof. Zainal mentioned just now is about, I remember one of the slides show about the virtual power plant. All right, how this IR 4.0 come in? All right, IR 4.0 coming into one of the cluster inside the energy transition. Under this energy transition from migration from the conventional to renewables and also alternative perhaps one day, all right, we need to see the embracement of this IR 4.0. Example of it is I can see here is a virtual power plant. It's very important where everybody, if Prof. Zainal mentioned just now and during early stage of presentation, is about producer and consumer. But now we have a term which is prosumer. I also can produce, I also can consume via mechanism of net energy metering and so on. All right, beside that, I jot down here is actually the Internet of Everything, but also Internet of Energy. People have been coined about the issue of Internet of Energy. Energy is a security, self-healing, and in the context of smart grid, we need to know we have a very good power quality, but how to reduce non-technical losses and technical losses. Right. This is important for the smart grid deployment in Malaysia. We cannot keep producing electricity but don't use it wisely or prudently. But the demand side management is very important. Correct. On the other side, maybe Prof, try to answer why Melaka. I think I need to be fair and honest to the person questions. All right, to be frank, all right, we have the demo project. Demo project is a term of pilot project in Melaka. Okay, if you know the grid infrastructure network in Malaysia, I think yesterday one of the professor mentioned about the grid connectivity. Okay, I think Prof Ong, with the credit Prof Ong, mentioned about the grid system in Malaysia. All right, one of the example, the demo project is actually in Melaka. After that, the grid in Melaka is connected to the neighboring states. All right, example Penang, example Negeri Sembilan and Johor. All right, the next, why not Putrajaya? All right, with the consent from TNB, I think because of we had done this type of extensive literature review. All right. TNB and nationwide, we did have a rollout plan of this smart meter and also smart grid project. So nationwide is being covered, Putrajaya. Don't worry. Demo project in Melaka, we have many justification why Melaka is in terms of grid readiness. Besides that, we also need to take care the grid security. But Putrajaya, Cyberjaya, Penang, Melaka, and also other states is inside the radar. That's rest assured.
So that would be like the next part of the implementation.
They call it, I think, smart meter rollout plan.
So I would assume that with the IoT and everything, then the term, somebody here asked the term cyber security. So I guess those will be in place as part of the elements that has to be looked into, regardless from maybe from the policy point of view or regulatory framework point of view, or perhaps in terms of the actual hardware demonstration project. There's one interesting question here. For the case in Malaysia, would you agree that financial incentive for both prosumer, power producer would be a major push in reaching smart grid? So I believe they wanted to know whether the financial incentive is the main factor to get this smart grid initiative to work. Maybe Arkaha, if you want to add anything from there.
All right. Thank you, Prof. Izam again. Okay, I would like to share previous engagement at MIC where we received a lot of way back to 2015, if I'm not mistaken, we received a lot of white paper, green paper, where a lot of high-tech industry, they want to either expand their operation in Malaysia or new influx of FDI, high-tech industry coming in. All right. In terms of financial incentive, I can say it's not the decision factor. Prof, it's not a decision factor. It's not just the cheap electricity they want to come in here. Some industry player, they choose Malaysia apart from political stability, geographical, natural disaster kind of robust enough, but also in terms of good power quality. I think the expert, Prof. Izam and Prof. Zainal, the high-tech industry and the normal type of industry is migrating from the cheap electricity kind of stuff into a very good power quality. So this is their main, to some reason, to some extent, they have this type of angle. Another one is actually some big conglomerate internationally, they just not just looking at, okay, as far as I have a good power quality, or I have a good electricity, I can come into Malaysia. This is not just the decision factor, but the other deciding factor is actually because of they have this environmental sustainability responsibility. One of the example I think everybody made known, a very big conglomerate in terms of hypermarket, they came in because of they are obligated to have this environmental sustainability responsibility. That means they have everybody well known a good manufacturing practice, but they also have green manufacturing practice. So where the source of electricity is also will be a decision factor. That means in Malaysia we have our good well of energy mix, from mix of conventional as a base load, and then we also have the peak load kind of renewable energy. So these are the holistic approach that we have to look.
So you have other factors that come in. Okay, that's very interesting. Maybe one for Prof. Zainal. There's a question here. We talked about the Smart Grid Demo project in Melaka, which is currently in progress. And some were arguing like, yes, maybe high cost in actually implementing the Smart Grid Demo. What about looking into a simulation platform, or maybe a hybrid simulation platform to it? So what's your take on that?
I think it's very interesting. I like the idea basically. Of course, when it comes to pilot and demo project, we need to put aside in terms of the cost, because everything, not everything, but some of the things must probably just try and error, to see how it well, integrated into the system. But when it comes to the simulation, this is particularly, I think, the value added when it comes to the implementation. Why? Because I think in many applications, what we are doing basically, at some point, we may not have, I would say enough budget, for example, or even enough technology, to be implemented in terms of the devices and so on. So as a researcher, this is our practice. How basically what we can do, we can take as close as possible, the real demo project and model it into the system. What kind of model or platforms is, it's depend, it's up to you. And then, so we're going to use whatever the output, from the real project, we're going to be validated with the simulations. So this is how it works. So it's just like, can you imagine one-to-one, similarity? Okay, then you have the privilege. Say if you have a good, agreement in terms of the output that you required, in terms of the result, efficiency and so on, then there's opportunity for you to further extend and also expand, the smart grid implementation. How, say for example, if you're going to have, like much bigger capacity of the energy storage, you can put in. In reality, you may not be able to buy it because it's very costly at the moment. So likewise, say if I need to have like more IED, intelligent electronic devices, to be implemented in the system, I may not be able to be, to implement in real practice because of most probably circuit complexity or cost, So that can easily be done, through the simulations. So this is the value added, when it comes to the research, which is, I think I found it like it's very beautiful in that sense, if you can integrate between the simulation and also the hardware implementation, or rather the demo.
So it's something like a hybrid.
Exactly.
You have the actual test bed linked together with simulation based work. Okay, that's very good. Maybe one last question that I can choose. Oh, let me see. There's a few interesting ones here. Okay, let's try this last question. It's by this lady called Ziana. Implementation of smart grid in Melaka also means transforming a brownfield infrastructure into a smart and sustainable infrastructure. In this project, could you please share with us what is the main goal and capability that this project aims to demonstrate to the world, since smart grid technology are already available? Is this project deploying any homegrown technology? So basically, I think the viewer here wanted to know, what is having the smart grid demo, what would be our main target? What is it that we want to demonstrate? So maybe Kaha, if you want to add to that.
All right, to answer that, thank you, Prof. All right, perhaps I would like to, if you can recall my previous slide, all right, at the international level, national level, and also the state level. All right, internationally, we have this, I can name it, Prof. All right, International Smart Grid Association Award. They call it ISGAN. Why this ISGAN is very important? Because the whole world one day is through globalization, all the connectivity of the grid is there. So we need to make sure our grid is competitive enough. So we need to be internationally by default, by hook or by crook, whether by force or whether through our willingness, we have to make sure our grid is ready. Then we stay competitive. Influx of high-tech industry investment will be in. All right, that's the we also have this SDG goal where we have to meet. All right, and then at the national level, we have to make sure our grid stability. We have, I think, in the context of what Prof. Zainal mentioned, we have 3E, but in the context of energy, we have 4As, which is, if I'm not mistaken, availability, acceptability, accessibility, and another one in the context which we are looking at 4As plus 1A, which is one more A, is actually about accountability. In this context, who will be responsible? Apart from we have TMB, we have National Electricity Company, other IPPs also. So we have to be accountability, and even myself. One day I will be the prosumer, producer, and consumer. So to drive this one, we have international, we have state level, we have national level goals. This is important. And then the state level, okay, we have to be really thanks to Melaka, because of the Melaka state have a very good leadership in deploying green tech cities for their states. So they have a lot of big solar farm. Okay, one of our slide mentioned they have 5 megawatt, they have 31 megawatt, they have 8 megawatt. I think which is to the Malaysian, take this opportunity, Prof, to go and visit. I think if I can share my previous experience, one of the solar farm, they have the biggest efficiency. And the Japanese came to Malaysia to really learn the local homegrown technology, as what being asked just now, the local homegrown technology, which is a very good farm scale size, which is 8 megawatt capacity. How, because of land scarcity and land sizing, they managed to get it 8 megawatt. Even the Japanese came there. I can recap this one, and perhaps those who ask the question can further communicate with Prof. Izam and Prof. Zainal to make a specific enrichment, how they really can study. I have to declare here, this is a very good site where, because of land size, which is having a very crucial and size constraint, they managed to get it 8 megawatt. The Japanese came because they are very curious. They say they did it in Japan, they required bigger land space. All right, so that's on the national, I've touched it, international, state level, and from the project point of view, the smart grid, yes, we have local homegrown technology. We even have this solar PV, where they install the locally made Malaysian solar PV panel. We have lightning arrestor, very good. We can validate with Prof. Zainal. For your info, all these solar farm, the main part, okay, they are very friendly with the climate lah, all right? They have sun, but they're also very scared of the lightning. Okay, with the wrong lightning design, lightning strike can easily hit the panel. So can cause a circuit break off. So this is something which is more technical. I leave to the lightning man to deliberate further, but the local homegrown is there. And apart from that, the national, in the context of TMB, Prof, since Unit 10 is here, they have to abide to the compliance of what ST decide on the SAIDI, CHIFI, and non-technical losses and technical losses. So everybody have their own commitment. At MIC, we need to drive high-tech technology industry development via having a very good industry development here. All right, with that, I hope I can answer.
Thank you very much. I think we can't answer all questions because we'll be here the whole day. So maybe we can, before we end, maybe a concluding remarks from both of you. Maybe we start with Prof. Zainal.
I think it goes with my title, which is Smart Grid, a really solution to the energy trilemma. And we, I mean, as a nation, whether you are prosumer or you are consumer or you are the producer, we can all play our parts. How? Through all the smart grid elements that I've shown earlier. But of course, we have to look into different perspective, especially like with the advantage of the smart grid demonstrations. If you are looking for the FDI, for example, so we have to make sure we have something as what we call the grid of the future, very resilient grid, connected grid, and also flexible grid. So these are all the key points that is currently being focused by all the utilities in the world. It's connectivity, it's flexibility and resiliency of your grid. So we can all play our role. Thank you.
Thank you. Arkaha?
Okay, I would like to recap again my the title of my knowledge sharing for today, Prof. Actually, it's a journey, and the journey is belong to whom? Belong to all of us.
Yes.
Belong to Prof. Izham, not just belong to the two panelists, but belong to all the Malaysian and also to the global human being. Because trust me, the future of the energy transition is the grid is well connected, and in the context of Malaysia, everybody have to use their grid wisely, meaning to say our home electricity, we have to use it prudently. Therefore, the national energy producer and national energy generator won't get headache to manage the demand side management. So everybody play their role. And from mine is a journey towards high-tech industry development in the context of energy sector. Without electricity, and these are the basic need that everybody need to have electricity nowadays. This is a very basic need. This is a city function that we have to have a very good energy. The way forward, not just having energy, but a very good power quality of energy, well spent, prudently use of energy, and the social obligation. I think maybe to the world, every religion did promote, don't waste. Have a very minimum with have more with minimum. And in the context of COVID, I think whole world is having this disaster. Energy is important. We cannot have very good resilience in terms of healthcare without the energy. We need to say we must use our energy wisely. With that, thank you so much, Prof.
Thank you very much. So that wraps nicely on our discussion today to kick off the Smart Grid Roadshow. We've discussed a lot of topics, a lot of points related to Smart Grid and the energy trilemma. I think there were a lot of interesting questions, so thank you to our viewers for actually giving some interesting questions, and I believe most of them gave good comments. It's a good start for our promotion. So before I pass to the MC for today, I would just like to remind all the viewers, please follow our Smart Grid for Sustainable Cities, Smart Grid for Smart Cities in our Facebook and Instagram. I think it will be shared later. And based on that, there'll be more awareness campaign and videos and sessions, be it maybe through videos or maybe online shows. And there was one request to also wanted to know the series of trainings that we had. So with Mike's permission, then we'll probably share the schedule. Then maybe we'll share the joint link for those who are interested to do so. So with that, thank you very much for your time. It's a very interesting time now, and let's hope to see the future will be great and see how this smart grid will work for Malaysia. So thank you very much. So over to our MC.
Thank you, Yang Berbahagia Professor Dr. Izham, Professor Dr. Zainal, and Insinyur Arkaha for a very insightful speech and discussion. It is such an interesting elaboration of the issue, and we hope our honorable speaker provides additional insightful knowledge for us in transforming the society. We have now come to the conclusion of today's events. On behalf of the organizing committee, I would like to express my utmost gratitude to all distinguished guests and participants for making this event a success. Also to thank Uniten and our co-organizer Mike and Unido. Without them, we cannot realize this program. And it has been a great day and a wonderful morning with the presence of all of you. Please allow me to read a quote by Stuart Brand, an author and innovative thinker. We can see the past, but not influence it. We can influence the future, but not see it. Let us be guided by all the things we have learned and heard throughout the Smart Grid Roadshow and be able to see and influence our future. See you next Smart Grid Show. Thank you.